Okay, that last one went pretty long. I'm going to try to talk less and just show you how to do it a little bit more quickly. Fill in the blanks for the sentences below. To save time and expense, a statistician took a random sample. That's sampling is when you choose things from a bigger group of things, right? A random sample or sampling from a population is any group you're trying to study. Population. If the wording of a question is poor, then your survey will be biased. That is unfair, somehow skewed, slanted, unfair. Okay, those are all good words. The empirical rule is the one that says that if you have a normal distribution, and if it does not say so in this problem, that's me forgetting to say so, because you really should, when you ask a question, say that normally distributed. But we can assume that it is, and then we have this breakdown. That's our empirical rule that says that this is 34 and this is 34, and this splits things into halves. So if this is 76 and the standard deviation is every 10, there's 86. Out here it would be 96, there would be 66, but we're really interested in what percentage is in here, and that's going to be 50 plus 34. So 50 plus 34% is equal to 84%. Alright? That's the empirical rule. Then you multiply that, times 750. So 750 times 0.84. 750 times 0.84. So around 630 students. And that, of course, would be approximate. In the real world, it's not going to be exact, so that's why that is worded as approximately how many. A scientist wants to show how population of bald eagles varies over time. If you're doing something that's over time and you've got years going like this, there's time, and you've got population, that is so going to be a fixed point there, and the population is going up like this, and then maybe it's coming down like that. That is going to be a broken line graph, okay? So just remember that broken line graphs are sometimes not appropriate when there's no reason to assume that in between these years the population is not in between. But in this case you can assume that even though there's no such thing as a half of an eagle and there are individual population points, that basically you can model this by connecting the dots. Broken line graph, okay? How many ways to address yourself with each of the following choices? 1, 2, and 3. 10 times 6 times 7, that is equal to 42 times 10 is 420. Okay, pretty straightforward. How many passwords? A password is very much, it's important that you have the order correct. In this case, you can think of it as fill in the blank. 1, 2, 3, 4, 5, 6, 7. You have 7 blanks. 5, 6, 7. You can have 7 choices for the first letter. You're rearranging all of these letters. 6, 5, 4, 3, 2, 1. That's 7 factorial. What is that? Find out how to do this in your calculator. Math, whoops, clear that. 7, then math, PRB, 4, hit enter. 50, 40. 50, 40. Okay. How many passwords can you make rearranging any 5 letters? 1, 2, 3, 4, 5, 6, 7, 8. Again, passwords order is very important. That means P is NPR for password. So this is going to be 8P5. If you didn't have a calculator and didn't know, it'd be 8 factorial all over. When you subtract these two, 3 factorial. Okay, so that's going to be just fill in the blank. 8 times 7 times 6 times 5 times 4. Okay, I'm losing valuable time here if I do that, but 8 times 7 times 6 times 5 times 4. 6720. Alright. Now on to what is the probability of 8 coins landing showing 5 heads and 3 tails. Do I even need to write this? No, Could just say that, because if it's not this, then it's tails. That is going to be how many ways can this happen? Well, that is where NCR comes in. It's 8C5. That's the number of different ways from Pascal's triangle over 2 to the 8th. Okay, that is the way you figure that out. I won't explain it now, but it's been explained elsewhere. So I do 8 and then math, and NCR is 3, and then 5. Hit enter, so it's 56 over 2 to the 8th. 2 caret to the 8 is 256, and so I'm going to do 56 divided by 256, and that's going to be approximately 22%, okay, or 21.9%. What is the probability of choosing 5 black marbles at once? And choosing at once is no different than choosing one, and then another, and then another, and a fourth, and a fifth, and then looking at them. So you have to think about it as one after the other. 12 black and 8 white, that's a total of 20. So 5 black will be 12 out of 20 is the chance of choosing my first one black. When I've got a black one in my hand, it would be 11 out of 19, and then 10 out of 18, so that goes down 9 out of 17, and 8 out of 16, okay? And you can play the game of canceling. There, the 8 cancels with that, I get a 2. The 9 cancels with the 18, I get a 2. The 10 cancels with the 20, and I get a 2. This 2 and this 2 make 4, and they both cancel with this 12 and give me a 3. Still got that 2. The 19 and the 17 won't, so it's going to be 33 over, that's 3 times 11 over 19 times 34. 19 times 34, it's 17 times 2. So that makes it just at least a little bit easier. 33 divided by, in parentheses, 19 times 34. You can also just stick it all in your calculator and do it. That is approximately 5.1%. Okay? So there's that one. What is the probability of rolling double sixes, called boxcars? You don't need to know that with a fair dice. Well, that's 2 sixes. So getting 1 6 is 1 in 6. Getting another one, you multiply 1 in 6. So that's 1 in 36. Okay? What is the probability of rolling a total of 5? So I can get a total of 5, that should say with 2 fair dice. 2, that is a real typo, because, I mean, you can kind of imply that, I guess, but, so that would be a 1 and a 4 and a, 1 and a 4 and a 2 and a 3 and a 3 and a 2 and a 4 and a 1. Those are the only ways out of 36 ways that will give me a total of 5. So that makes it 4 out of 36, which means it's 1 out of 9. That's the probability of rolling a 5. What is the next number of Pascal's triangle? What you need to know from back in the day of doing this is that it's NCR, but we start with 0. This is the 0th number. This is the row number for row 1. So this is 50C1. Check in your calculator. This is 50C2. So this one here is 50C3. Your fourth number is always one less. So I do 50 math, NCR, and 3, and hit enter. 19,19600. Okay, so that's that answer. Design and carry out 10 trials of a simulation that will answer the following question. Explain each step. 3 waitresses are going to add up their tips. They know from experience they make between $10 and $30. What's the probability that they will contribute more than $50? All right, so in designing a simulation, the steps would be like, well, how are you going to do this? I'm going to start with my rand int on my calculator, random integers, and the lowest it could be 10. The highest could be 30. This is not a percentage. I'm not saying what is the percentage of anything, so we need numbers to simulate their actual tips. that are randomly given out between those amounts, and then I'm going to press enter. When I've done this 3 times, and that equals 1 trial. Okay, so let's do that. So I do randint math probability randint is option number 5. 10, the comma's above the 7, don't forget that. 30, close parentheses, and I hit enter 3 times, and 26, 26, 16. Okay. Now I would add those up. In this case, that's 52, 62, 68. So the total, so that's what I do for step 3. Total, 3 numbers. Step 4 is total greater than 50? Question mark, question mark. If so, then I don't know, you can call that happy face. It's usually you break these things down into something that's good. Maybe your rain is not coming on your soccer tournament, or something that's bad where you get rained out. So 68, I'll write it there, and I'll do this 10 times, and I'll write the totals in so I have a record. Okay, I'll just do this one more time. 1, 2, 3. So 27, 25, that's 58, 69. Okay, so I will do that 10 times, and then I'll figure out tally and find percent over $50. Okay, and then that's the probability that they give more than $50 to the fund. All right, so there you go. That's another installment.